Okay, now I can finally delete these two slider nodes, but before I do, I want you to notice something. Look at the wires going from my normal map and then also from the gloss slider. You'll notice that the one from the slider is a single wire, whereas the one from the normal map is 3 wires. The reason for this is that the wire for the normal map is actually sending 3 pieces of data. It's sending a red, green, and blue color channel. So it's a 3-channel RGB image, so there are 3 wires to represent that. Gloss is a single black or white value, so only 1 channel worth of information is being sent. That's why the wire is singular. What this means is that when you're plugging in a value into roughness, we can only send a single channel's worth of information. You can't connect an RGB color to roughness or metalness, or most of these attributes actually. We can only connect a single channel. So I can drag out, instead of from RGB, just from the green channel to roughness. And now you'll see our dirt on top is very rough, whereas the paneling on the side is very shiny. Now it's a little bit too shiny, however. Before we continue, I'm going to really quickly connect the metalness channel. So now you can see it looks a little weird because we haven't put our paint on it yet, but you'll be able to see in some areas like these vents right here, they look a little bit different. They look more metallic because they're made of metal. Let me delete that real quick. And let's talk about that shininess for a second. What's happening is that Unity and 3D Coat interpret roughness values a little differently. If I go into 3D Coat and I bring back all of the regular texture maps, you'll see that even though some bits of our paint look highly specular, it's not nearly as much. Actually, let me take away the paint so it looks the same. You'll see that our metal here is not nearly as reflective as it is here in Unity. And the reason is that Unity interprets a 0 roughness value or interprets low roughness values very differently from 3D Coat. So we need to actually counteract this. And the way we're going to do that is with a special type of node known as a lerp node. So I'm going to hold down L and I'm going to select lerp. Now lerp is short for linearly interpolate. What does that mean? Well, let me show you a little example. What lerping does is it allows you to transition between 2 separate textures or 2 separate values based on a third value. So here in this case I have this grass texture and I have this rock texture. Now if I wanted to make a shader where I overlaid a little bit of grass onto the rock, I could use a lerp node in combination with some other texture. Here's how this works. What I've done here is that I have taken this noise map that I made and I have plugged it into the alpha channel of the rock texture. Now what's going to happen is this allows me to interpolate or transition from the rock to the grass based on the brightness values of this texture. So if I bring back the grass here, then you'll see that wherever the flame was black, we have gotten the grass, and wherever the flame was white, we have gotten the rock. And if it's a gray value somewhere in between, then it blends between the rock and the grass. So right here on this little transitionary area, we have some texture that is slightly rock, but also slightly grass. And the relationship for how it transitions between these two is a linear one, hence the term linearly interpolate. So what this allows us to do is select two values based off of a third value. So black will give us one value, white will give us a different value. Now, how are we going to use this here? Well, what we need to do is we need to use the roughness value from our material mask as that third value, as that transition value. Now for A and B, what's going to happen is that we are going to choose new roughness values based on that. Let me set this up here really quick. Now, because only our minimum roughness seems to be the problem here, I'm only going to give the user control over the minimum roughness, not the maximum roughness. So I'll select a value here. I'll call that 1. Plug that into B. Now, the B input is what you get with a white T input. So in the case of our grassy rocks here, white would be, the B channel would be the rock, because wherever it's white, that's where we get the rock. And the A input would be, which is the black input, would be the grass. So then for the A, I'm going to use a slider, and I'm going to call this roughness min. And I'll set this to be a maximum value of maybe 0.5. And I'll plug that into A. Now what that's saying is that now, wherever the roughness map is 0, wherever the roughness map is black, we're going to replace that instead with some other value. So watch what happens to the lerp node as I adjust this roughness min. You see that it becomes brighter and the contrast starts to lower. Now what this is also doing is it's not just clamping the values to some arbitrary minimum that we choose. It's adjusting, it's scaling all of the other values in between. So if a roughness value was 0.5 here in our base material mask, when we increase this slider, that 0.5 might go up slightly to maybe 0.6. The whole thing is becoming brighter. And then we'll plug the output of that into roughness. And you'll see that looks a lot better.